Colleen Lewis is a computer science faculty member at Harvey Mudd, and her research on college computer science education unpacks some of the ways that faculty and student mindset influence the learning process. And so she's also done a lot of thinking of how to practically take the idea of mindset into her own classroom. And we'll hear from her now on how she brings growth mindset into her teaching practically, as well as her own research.
So my name is Colleen Lewis. I'm a computer science professor, and I really try and integrate challenge and a growth mindset into my computer science teaching. So I think a really common assumption is that there is some innate ability for computer science or math or in other domains as well. And this assumption that there exists an innate ability for things is really limiting. Think of how scary an educational context can become for a student if they believe that. They think, eek, if I can't do this problem, it must mean that I don't have that innate ability. I'm not smart. And so it makes everything threatening and everything scary. And so what we want for our students is for them to think of challenges and opportunities to learn from errors as really like these beautiful opportunities, not defining who they are or whether or not they have intelligence, but as opportunities to learn and on this path towards a growth of their intelligence and their skills and their content knowledge. So that's the really big difference is, are we framing the learning process as proving whether you have something or not, or are we framing it as this, this climb, this challenge of really growing your knowledge and intellect? So I think it's really important to share my own experiences of struggle with my students to help them understand that when they're having trouble, when they feel like a task is impossible, that I've been there too, and that process is really a normal process in learning and a normal process in computer science. And so I share with them some of my scores from intro computer science courses, and I share stories with them of when I wasn't using effective strategies in my computer science class to learn and had to drop the course because it was going so poorly. And so I share those experiences with them, knowing that they already respect me and helping them understand that it can be a bumpy road. And even if you get an F in this class this time you take it, that just means you don't know the content well yet. And I had times where I clearly didn't know the content yet and did very poorly in different parts of the classes, but it was just a step along this trajectory to where I am now. An important place where I think about having a growth mindset is talking to students about their past performance on an exam. So they come to me very often and say, I did very poorly on this exam. Am I going to fail the class? What's going to happen? And embedding ideas about a growth mindset into helping them strategize how they're going to go from right now where they have little conceptual understanding in the class and poor performance, and how are they going to transform the strategies they're using to learn the content so that they can eventually learn it, right? And framing it as you don't know it yet. And so we have a few weeks behind us, and what are some of the strategies you're going to need to take to catch up? And that catching up is possible because you just don't know it yet. And what can we do so that you can get on the right path?
So another practical approach to bringing growth mindset into the classroom comes from my colleague John Bender, who's an instructor at Boise State University. And he has this really nice diagram that he includes in his syllabus where it shows how students might come in with different background, but that during his class, they need to improve both their content knowledge as well as some of their more general STEM skills, such as collaboration or communication. This emphasis that John's syllabus diagram places on recognizing students' history before coming into a course is incredibly important. Both students and instructors can easily mistake background for intelligence or ability. And so Colleen is going to share some research with us on the role of background in success in certain computer science courses.
So when I was TAing at Berkeley and researching the computer science classes at Berkeley, we found that in the second semester course, which is called a data structures course, women were just not performing as well. No matter who the instructor was, there was a gender gap in performance. And so there was a narrative in the community of just that women were just not as good at data structures. And we didn't know why. There wasn't a performance gap in the intro course. There wasn't a performance gap later on. So there was something about this course. And we thought it was the data structures content specifically. And when we looked at it more, we found that actually if we controlled for whether or not they had experience with the language, the programming language that was used in that course, there was no gender gap. So what we had is we had a structure set up so that people who had this prior programming experience before college, which was disproportionately male-identified students, then you were going to be successful in this second semester course. And it didn't show up in the first course because we didn't use that language. And so it was something that we needed to think about in structuring our curriculum so that we're supporting all students in being successful, no matter their path into the major. And that this disproportionately affected women because women are less likely to have taken AP Computer Science, which uses the programming language Java that we used in that second semester course. One thing to add to that is, the reason why we found out that actually it was whether or not students had this Java experience is because we weren't satisfied with this narrative that women just happen to be less good at data structures. And so it's about questioning these cultural narratives about who can do this and who's good at this, and digging deeper to see if there's a performance gap, can we understand why that happened? Are there causal mechanisms that might help us understand and change this performance gap?
We've heard a lot about this idea of growth mindset in this video, and in particular, we've seen the impact of both instructor and student mindset on the learning process, and then a couple of really important pieces for us as instructors to keep in mind. And the first piece is understanding the role of background and not mistaking it for natural ability, and kind of considering how we can support students coming in from various different paths. A second piece is the importance of our framing learning as this hard work and skill development, and really bringing to light all of the important skills needed to succeed in STEM. And lastly, the more we can do to normalize struggle, that STEM learning might involve some frustration and that can be hard when we haven't developed certain skills yet. And even still, a lot of research ends up being frustrating. It's a part of doing STEM. The more we can normalize this struggle, the better.